Section 5.2, logarithmic functions. So we just took a look at the exponential functions in the last section, and we looked at y equals b to the x. And b was a base. It had to be positive, but not equal to 1. And that's going to be true as we look at logarithmic functions. We're going to have a base as well. And for easier transition from the exponential logarithmic functions, we're going to look at x equals b to the y. And we have these logarithms of x to the base b, and it's denoted y equals log base b of x. These two functions, the logarithmic and the exponential, are going to be inverses of each other. And after we go through the basics of this, then I will show you what that looks like on a graph when you have these inverse functions of exponential and logarithmic. So log base b of x, if and only if x equals b to the y. And again, this is really important, that base has to be positive but not 1. So here's some examples of logarithms. So we have log base 10 of 100, and that's going to equal 3 because this base 10 to this exponent, so 10 to the third power, is equal to 1,000. So we're going to have to be able to go back and forth between exponential and logarithmic functions. And it's important to understand that this is always the base. So log base 5 of 25 is equal to 2 because 5 to the second power is equal to 25. Here I have log base 7 of 7. It equals 1 since 7 to the first power is equal to 7. And log base 3 of 1 over 27 is equal to a negative 3 because 3 to the negative 3 power is equal to 1 over 27. We're going to be solving equations with these, both exponential and logarithmic, so we're going to have to be able to go back and forth between the two. Number 5, solve for x. Log base 3 of x is equal to 2. So I'm going to do a rewrite. The base is 3. That's the exponent. So 3 to the second power is equal to x. And 3 to the second is 9. So we get 9 is equal to x. Number 6, we have log base 16 of 4 is equal to x. So the base is 16 and x is the exponent. So 16 to the x is equal to 4. And remember in the last section we rewrote these. If we can get the bases the same, the exponents have to be equal. So 16 is 4 squared. And that would give me 4 to the 2x is equal to 4. And there's nothing there, so that exponent is 1. And I can write those 2x is equal to 1. Therefore, x is equal to 1/2. And then for number 7, I have log base x of 8 is equal to 3. Again, this is the base. This 3 is the exponent. So x to the third power is equal to 8. And I can take the cube root of both sides. And we get x is equal to 2. So logarithms, again, the base can be anything as long as it's positive and not equal to 1. But there are common ones that we use all the time. And those two most common are the common logarithm, which is base 10, and the natural logarithm, which is base e. And remember I said e is called the natural number, so that's why they call it the natural logarithm. These are the only two that can be evaluated in most calculators. So if you don't have these bases, you have to do what's called a change of base in order to get them into, be able to evaluate them in your calculator. So the laws of logarithms, these are really important. They're related to the laws of exponents. So the first one is, if I have this thing multiplied when you expand it, it becomes an addition. So remember when we were multiplying with the same base, you added them together? This is related to that. So each of these are just inverses of laws that we already use for exponents. So I have, if they're multiplied, when you expand it, it becomes an addition. And this arrows I have going in both directions because I can take something that's expanded, if it's an addition, and put it back together and it becomes a multiplication. So these laws go in both directions. If I have the argument that's divided, when you expand it, it becomes a subtraction. And again, remember we had the rules of exponents. We subtracted when there was a division. When I have something to a higher power, you multiply it out front. So if I have something like m squared, that 2 could be multiplied out front. Log base b of 1 is 0 because remember, this is the base to that power is equal to 1. So anything to the 0 power except for 0 is equal to 1. And log base b of b, so if these two things are exactly the same, that's equal to 1 because again, b to the first power is going to equal to b. So we're going to have some examples here. The first one, log of 4 times 5. I can expand it by doing log of 4 plus log of 5. Log of the square root of 5. Rewrite that square root as an exponent of 1/2, and then we can multiply it out front. 1/2 log of 5. Here I have the natural log of 7/8. So this is divided. So when I expand it, it becomes a subtraction. Log base 37 of 37. That equals 1 because 37 to the first power is 37. And log base 5 of 1 is equal to 0 because 5 to the 0 power is equal to 1. So here I have some expansions. And I'm going to write these out so you can see exactly how they work. And I'm given that log of 2 is approximately 0.301. Log of 3 is approximately 0.477. And log of 5 is approximately 0.699. So that's what our givens are. And we're asked to find the following. So log of 15 is the first one. Well, 15, these are only things that I know, right? So log of 15, I have to rewrite it using what's the given. So I'm going to rewrite it as log of 3 times 5. And then I can do my expansion. That multiplication becomes an addition. So it's going to be log of 3 plus log of 5. And then I can do the substitution in. So that's going to be 0.477 is log of 3. And 0.699 is log of 5. So that adds up to 1.176. B is log of 25. So I can rewrite that as log of 5 squared. And then I'm going to use that property that says if I have an exponent, I can multiply it out front. So 2 times log of 5, which is 2 times 0.699. And I get 1.398. You also could have just did log 25 is log of 5 times 5, and you get the exact same answer. C is log of 30. So 30 is going to be 2 times 3 times 5. And then my expansion, because they're all multiplied now, I can rewrite it as log 2 plus log 3 plus log 5, which is going to be 0.301 plus 0.477 plus 0.699, and that adds up to 1.477. And then D is log of 7.5, which is kind of weird. But 7.5 is 15 divided by 2. So I'm going to do log of 15.